Hi, my name is Haley Granger, and this is our user interface engineering project. Our topic is emerging techniques and technologies of artificial intelligence and machine learning. Our group members are Leo, Tyra, Haley, and Jaspinder. So, a summary of our project, we focus on artificial intelligence and machine learning and how it has revolutionized our world today. We talk about how AI and machine learning have contributed to medical fields, the business sector, research areas, and much more. We also pose questions such as what are the platforms that AI is used on, and how are AI and machine learning used to work efficiently? What are some other related words in terms of AI and the marketing implications of AI? Artificial intelligence and machine learning have revolutionized our world today. It can assist humans in research, medical field, our daily lives, and more through automation. Our research focuses on the topics in AI, such as enabling technologies, architectures, platforms, optimization techniques, evaluation metrics, market implications, related works, and the challenges and limitations of AI. The first section that we will look at is enabling technologies. In order to understand AI, it's important to understand expert system programs, or ES programs, which are computer programs which are derived from a branch of CSR called AI. AI is part of expert systems, and to implement AI and other techniques such as rule-based learning, machine learning, and genetic algorithms, expert system programs are needed. In this section, Enabling Technologies, we will focus on rule-based learning, artificial neural networks, hybrid learning systems, and genetic algorithms. So our first method is rule-based learning. Rule-based AI is conducted by giving a set of conditions in the form of an if-else statement. This will help the AI to determine what outcome to portray or predict. This form of learning is easy to maintain, implement, and easy to understand, since the way that knowledge is provided to the system is straightforward. The problem with rule-based learning is that there is no real learning in rule-based learning. Therefore, rule-based learning is only useful if a pre-existing knowledge base is available for use. As you can see in the figure, you have some input data. You linearly transfer it through some data analysis into the rule-based system, and it outputs predictions. The next method is artificial neural networks, or ANNs for short. These techniques are inspired by the human nervous system, and this allows for the AI to learn and understand concepts through training, similar to a human brain. ANNs are useful when solving problems and that require a lot of data. And this figure shows neural network architecture types. There are many different complex architectures, and these are some main ones, such as perceptrons, recurrent neural networks, the hot field network, LSTM recurrent neural networks, etc. Another method of AI is hybrid learning systems. Hybrid system learning is a method that is an extension of an ANN, or artificial neural network. This technique is a combination of training the AI with the ANN technique while adding additional information that the AI did not learn during training. It's useful because the system is expected to learn more when including extra learning materials that the system didn't learn initially. As you can see in the figure, you have the initial knowledge, the rules of the network, being fed into this initial neural network, and then that being changed through neural learning into a trained neural network. There are two inputs for this trained neural network, the initial neural network and training examples. Another method are genetic algorithms. Genetic algorithms is a technique that is inspired by natural selection, much like other AI-inspired methods. This technique evolves new possible solutions to a problem based off pre-existing solutions over time. This algorithm keeps evolving until the problem is fully solved. As you can see in this figure, it portrays these genetic algorithms in terms of genes and chromosomes. So you look at a certain gene and you change things little by little in order for the AI to learn. Now we will discuss architectures and platforms of artificial intelligence. Before talking about the architectures and platforms, it's important to mention that there are many different benchmarks for AI, and these benchmarks are designed to check off certain AI milestones. One of the most famous ones is called the Turing test, which tests to see if an artificial intelligence computer can convince a human that they think and act like a human as well. So we will go back to artificial neural networks because they represent a simple and complex architecture of AI. They mimic biological neural networks of the human brain, and their basic architecture is they have input layers, hidden layers and activation functions, and an output layer. And in this figure, you can see you can have any number of input layers that feed into this hidden layer that has these activation functions along the way, which then feeds into more hidden layers if you decide to create them, and it will feed into sometimes a single output layer, sometimes more. So artificial intelligence in user interface design is also important to note, and there are two main categories used for artificial intelligence in UI right now. You have AI for optimizing user interfaces and AI for creating user interfaces. There are multiple libraries and functions of different programming languages that can implement AI seamlessly. Python is the most popular one for easy implementation, and Keras, TensorFlow, and Pandas are the most popular libraries. They allow for programmers to implement these artificial neural networks and other methods of AI without having to recreate the wheel. So some optimization techniques in user interface engineering in relation to AI. It's important to talk about the keystroke level model, KLM, and goals, operators, methods, and selection rules, or GOMS. And these tests help with human-computer interaction prediction. They basically have different methods and benchmarks to look at to see how humans interact with computers and how different artificial intelligence methods can train those interactions to help with better user-face engineering. So the keystroke level model for prediction is broken into several different areas. You have K, P, H, D, and M, and these are the main variables that go into the model. K is for keystroke, which maps each keystroke or button press by the user. P, it means pointing, which means the time it takes for the user to point at a target. H is homing, which means it tracks the time it takes for users to interact with multiple devices and return to the original device. D is drawing, which is the time it takes for users to draw two line segments using a mouse. M is mental, which means the time it takes for users to make a mental decision about a task. On this slide, these are some evaluation metrics used in artificial intelligence and machine learning. You have mean absolute error, recall, precision, true positive rate, true negative rate, accuracy, logarithmic loss, and different accuracy prediction. So there are many different methods in related works that we found. In our paper, we described the different methodologies that have been utilized in many of the emerging technologies we see today. Though many of the newer and more efficient technologies use methods that are more complex, at the core of them all are the fundamentals we cover throughout our project. The related works can encompass all fields of AI within different practices because AI's basic function has always been kept the same, which is to mimic the human brain and to increase predictive and automation efforts. For our market implementation section, we focus on general market implementations, which include increased communication, increased automation, enabling the production of smart technology with the ability of solving and assisting problems. And AI has a lot of other potential for problems that have yet to be solved. In terms of commuting, AI has helped to improve commute time through Google Maps. We have Uber, Lyft, and displaying the fastest route through vector transformations. In emails, AI allows emails to create rule-based filters that can filter spam. Gmail ends up filtering 99.9% of spam and also classifies your messages into primary social and promotional inboxes and significant messages. AI also creates smart replies that are natural to the human language, and eventually AI will hopefully be able to predict and give progressively complex reactions in their smart replies. In terms of grading and schoolwork, AI has had plagiarism checkers such as Turnitin and robo-readers that allow for schoolwork to be double-checked. In terms of finance fields, stores check through wireless applications. AI can check handwriting and investigations into texts. It can predict fraudulent exchanges or identify them, check to see if there are too many exchanges on a daily basis for people that don't normally have that many exchanges. And when applying for a loan or a credit card, banks need to decide to acknowledge or deny applications, and AI helps with that as well. In social media, AI is a big factor into the facial filters that a lot of people use on social media. It goes into face highlighting, object identification, recommending similar posts, replacing text with emojis, the Snapchat face filters, tracking facial movements, showing relevant products, recommendations, and voice-to-text information. There are also Siri, Google Assistant, Cortana, Alexa applications now that use AI in order to make people's lives easier. So some of the challenges and limitations of AI. Data. It's hard to get enough and the right amount of necessary data for AI. We talked earlier about artificial neural networks and how they require a lot of data, and sometimes that can be a problem when trying to train data quickly. For example, in healthcare, if you look at entire human genomic sequences, they are gigabytes and gigabytes large of data just for a single human. And so in order for AI to better predict different diseases and ailments among humans, it would have to go through that entire database to make accurate predictions. And at this current stage, AI is too slow and not capable of using that much large data to do so. Also, multitasking. AI can't multitask yet, but there are different technologies that are working on it, such as Google DeepMind. AI also has a lack of insight, knowing how things are put together and knowing what information is going on in them. Humans are aware of certain outcomes and consequences of their actions and decisions. And while AI is currently working on that, it is hard to teach a computer how to learn consequences if there is no substantial data in what those consequences could be. So in conclusion, artificial intelligence and machine learning have evolved in different architectures and platforms across the medical field, the business field, and more. For us to better utilize artificial intelligence and machine learning in society, we need to weigh the pros and cons of these technologies, as well as examine its related works, how these algorithms are created, the metrics that measure these technologies, and more. When doing this, we can better understand emerging techniques and technologies of artificial intelligence and machine learning. Thank you.